Welcome to this week's midweek space news. I'm going to cover some of the space news this week with a focus more on the smaller space startups that other channels don't really cover that well, in my opinion. Before we get going on that, we have an X account. It's at Space Startup Hub, so you can find us on X. So let's get into the first article this week, and it's on ATMOS and Space Cargo Unlimited target first reentry mission in 2026. So this will be first of 7 free-flying orbital research missions where ATMOS Phoenix reentry vehicle will carry SCO's bento box platform. If you're not familiar with ATMOS, it's a German company that's working on reentry technology. It has an inflatable device, re-enter the Earth, and softly splash down in the ocean. And then you can recover the payload. So they've teamed up with SCU, which is Space Cargo Unlimited, and they're working on the bento box platform, which is for like experiments, biolife, and manufacturing in space. So by manufacturing in space and then teaming with ATMOS, they can return the payload to Earth. So ATMOS's Phoenix 2 vehicle will launch aboard a SpaceX Falcon 9 rideshare mission and conduct customer in-orbit experiments and transmit data home through ATMOS's comms and ground segment infrastructure. Phoenix 2 will blast through the atmosphere using its inflatable atmospheric decelerator technology, and I'll talk more about that in a minute. Phoenix 2 is planned to land in the Azores, and they will attempt a first water recovery. And the purpose of this team up is to provide European customers with sovereign access to in-space manufacturing and research destination, make microgravity manufacturing as routine and accessible as terrestrial production, an in-space logistics business model that can service customers after the International Space Station is decommissioned in the 2030s. So they plan to increase the cadence of Phoenix flights to 1 per month, with the potential to take 25 metric tons of payload to orbit in one flight and open the door for large-scale manufacturing in space. So that's the article. We have some video from ATMOS. I've previously done a video on the company. You can find it on the channel. But basically, this is the inflatable technology they're working on. And there's another graphic here that will show in more depth. So that's ATMOS being deployed from second stage. And once it's ready to re-enter the Earth, it inflates and then slowly come back into the atmosphere. And you can see here scientific experiments on board, manufacture things, whatever. And then once you've finished manufacturing and it's ready to come back to Earth, then it inflates and it's going through, you can see the payload there. And that's protected in the middle. Pressurized and unpressurized payloads, selectable temperatures. And then it inflates. This is an IAD, or inflatable atmospheric decelerator. So it can take air from the atmosphere and inflate. And then when it's at full size, it can come back through the Earth atmosphere. As you can see here, it gets very hot, but the material is strong enough that it won't burn or melt. So it can handle over 1,000 degrees Celsius, keeping the payload cool. It's got flaps at the side to steer it. And then a soft splashdown in the ocean. And this will be off the Azores, which is in Portugal. And then you can recover the payload. The idea is to do this on a frequent basis. We have an image. This is from ATMOS. This is in the Azores. So it's an island in the Atlantic Ocean. You can see here there's an ESA station here. So it's good for telecommunications. Recovering the IAD from the Azores shouldn't be a problem. Then they can send it back to the customer. So that's ATMOS, and they're partnering with Space Cargo Unlimited. And if you want to know more about ATMOS, there's a video I've done on them previously. I think I did this video last year. Okay, on to our next story. And this is a team up between Starcatcher and Intuitive Machines. So the tweet reads, and this is on Intuitive Machines' X account, powering exploration where sunlight can't reach. Moonracer Intuitive Machines LTV, or Lunar Terrain Vehicle, successfully received wireless energy from Starcatcher, proving compatibility with orbital power systems to keep missions running through the lunar night. We actually have some video, so let's just play the video and have a look at it first. So that's the beamed power coming from a Starcatcher device. This is the Intuitive Machines lander. Then you've got the Moonracer in the background. You can see on the left the trailer that will catch the sunlight as the Moon Racer LTV. One of the 3 vehicles NASA is considering to land on the moon. But in a moment, we'll see it receive beam. So this is a render of landing on the moon and moving around. And you can see the trailer on the left. So you can put all kinds of equipment there. So this trailer can receive beamed optical power. And you can see it from the Starcatcher device. And there's a receiver. And that energy can be used to power the Moon Racer LTV. Okay, that's the video. But as it says in the post, the idea is that when the sun goes down, it can receive beamed electrical power and keep warm enough that it doesn't freeze. The problem is that the lunar night gets extremely cold, minus 173 degrees Celsius, and that will freeze the electrolytes in batteries, for instance. It has to be kept warm. So one way is beaming optical power from somewhere that has sunlight. So it's an interesting idea. I've covered Starcatcher before, but basically they're building a in-orbit constellation of satellites that receive solar energy, store it, and then can beam it to client satellites. They beam the energy directly onto the solar panels on other satellites. The client satellites don't need any new equipment. The energy is just directed directly onto the solar panels, and they receive extra power. So they're building a constellation of satellites, and they've just tested their beaming system. I think it's over quite a long distance now. And as you can see in the video, it works for lunar terrain vehicles as well. And here's the Moon Racer vehicle. NASA is considering 3 LTVs, or lunar terrain vehicles. You have the Moon Racer for intuitive machines, you have Lunar Outpost Eagle, and you also have Astrolab FLEX Rover. So one of those will be sent to the moon, paid for by NASA. I'm not sure exactly when they're going to decide, probably next year. There's also a video if you want to know more about Moon Racer. I think I've done videos on all the companies at this point. So let's move on to the next article. The Nix vehicle by the Exploration Company, which is a European space startup, that's very well funded. I believe it's something over 400 million euros. So it's probably one of the top funded European space startups. And we have this article here. The Exploration Company tests Nix micrometeoroid shielding. So it goes on to say there's been a successful test of the shielding to protect the Nix spacecraft. Nix, which has been developed by the Exploration Company, is a modular, multi-role spacecraft expected to make its debut in 2028, and it will transport cargo to and from the International Space Station. They have a contract with ESA. They have a number of milestones they have to meet, but if they do meet the milestones, potentially they'll get a contract from ESA to deliver cargo. And missions to lunar orbit, lunar surface operations, and eventually even crew transportation. We'll talk about that a bit more in a moment. Initial test campaign of the spacecraft Micrometeoroid and Orbital Debris Shield, MMOD. Its shielding underwent hypervelocity impact tests at speeds of up to 9 kilometers per second, also successfully concluded an extensive wind tunnel campaign, and this is crucial validation for the Nix spacecraft design as the Exploration Company positions itself for Phase 2 of ESA's Low Earth Orbit Cargo Return Services Initiative. This is ESA's, the European Space Agency's initiative to fund low Earth orbit cargo transfer missions from private space companies based in Europe, one of which is the Exploration Company. So we have a few graphics from the company. I've done a video on the Exploration Company and the Nix vehicle, so you can get all the details from that video, but we'll quickly go over the Nix vehicle here. So it can carry up to 4,000 kilos or 4 tons of payload. The mission duration is 2 months, automated platform, and launch in 2026. This is an old graphic, so I don't think that's true. It's more likely 2028 now. We do have a video we can show you here. This is a render of the Nix vehicle, which you'll see in a moment. And there it is. It's a cargo vehicle, and it can be used to transport cargo to and from low Earth orbit. So it can send cargo up to commercial space stations or the ISS, can return cargo back to Earth. From low Earth orbit to the moon and back. So they do have plans to go further. So this is Nix Moon. They have 3 variants. You have Nix Earth for low Earth orbit, Nix Gateway, and then Nix Moon lander. They've also launched a small prototype. This is Ariane 6, the maiden flight, and you can see the small prototype here on the screen. Unfortunately, the second stage of Ariane 6 didn't do a deorbit burn, so it's still stranded in space and probably will be for the next 10 to 15 years, which is not good. They have plans eventually for a crewed version of the spacecraft, and there's a few mock-ups what it would look like. And we have a longer video here from the company. This is from some kind of presentation, so you can see the mouse sometimes appear, and that's just I screenshotted it from the presentation. So you can see Nick's Earth in low Earth orbit, berthed with the International Space Station. So they do have plans to go to the moon with Nick's moon. Now you can see it docking with the International Space Station with a robotic arm, and Nick's moon can land on the moon and take off again. So they've got very big plans, and like I said, they're well funded. That's Nick's gateway there. So we'll see what happens, but definitely interesting times in the European space capsule sector and in space operations. Okay, on to the next story, and this story is on a spacesuit being tested on the International Space Station by ESA, the European Space Agency. So here's the article: European spacesuit to be tested aboard ISS in 2026, and it goes on to say French astronaut Sophie Adenau will be tasked with testing a European Intravehicular Activity or IVA spacesuit. The French space agency CNES contracted Spartan Space, the Institute of Space Medicine and Physiology, and the sporting goods retailer Decathlon. The French Space Agency awarded those three companies a second contract in late 2024 to develop a prototype that could be tested aboard the International Space Station. The ergonomics of the suit will be evaluated with a particular focus on how easily it can be to put on and take off. Designed to be donned or removed in under 2 minutes. And this is Europe preparing for sovereignty in human space exploration. So Europe doesn't have a crew vehicle, but it has instructed the companies working on a cargo capsule to be compatible with the evolution towards a crew transportation vehicle. So I'll remove that. This relates to the previous article where we were talking about the Nix vehicle, which is a cargo vehicle, but it can be evolved into a crew vehicle. ESA's aware about that. This spacesuit is something that they're testing out. So potentially in the future, Europe can send astronauts to space with its own crew vehicle and its own spacesuit. Before we leave that topic, I want to talk more about Spartan Space. I've done a video on them before. So they're not just involved in spacesuits. Here's the spacesuit render. This is from a few years ago, so the design is slightly evolved. The spacesuit has changed. If we look at the latest images, this is the latest design, so different from the previous render. But they're working on a spacesuit, but they're also working on these inflatable hubs for the moon. So these aren't fixed habitats. They're kind of more expeditionary missions, and there's a video here we have a look at. So HLS, Human Landing System, landing sites, there's a Starship. You can see a rover, an LTV, Lunar Terrain Vehicle, and with 2 crew, and they're heading towards the excursion habitat, which is near a crater. So you basically put these habitats right on the rim of a crater, away from the landing site, and then you use an LTV to get to these new excursion habitats. And there it is. Journeyed from the base, you're at this habitat, and then you can spend a couple of days or a week or two, do some science, do some exploration. Potentially it's near a crater, so you do some work in the crater. And it's inflatable, and it's got skylight, so you can see outside. It's got power systems and communications. It's got solar panels on the side. So anyway, that's the idea. And there's various renders of the excursion habitat. And they've done some various mock-ups. And there's some more here. This is called EuroHub, and they're positioning it as an add-on to the Artemis base camp. This, as we could see in the video, allows you to move further away from the base and still have a habitat where you can stay for a small amount of time, do some science before heading back to the main base. So these habitats just get dropped on the moon's surface near a crater somewhere, and then you just drive to it. I've had my eye on Spartan Space for some time now. I've done a video on them. So it looks like Spartan Spacesuit will be heading towards the International Space Station. And on to our final story for this week. And this is on Astrolab. They're building the FLEX, a lunar terrain vehicle. It's one of the vehicles NASA is considering or evaluating for a mission to the moon. This will be a crewed vehicle that will help build the Artemis base camp and allow the crew to get around the moon and do some science and surveying. So the post says Flex is ready to take on the lunar surface. With a 2-ton payload capacity, our FLEX rover is prepared to support the needs of the lunar economy and construct necessary lunar infrastructure. Flex's airless tires have survived multiple tests in environments analogous to the moon's harsh conditions, possessing the ability to navigate terrain up to a 26-degree slope. From serving as transport for astronauts to autonomously deploying scientific payloads to laying out cable to support power infrastructure, Flex is flexible. Our lunar rover is up for whatever is needed to help humanity not just survive, but thrive on the moon. So we've seen Moon Racer already, and that is Astrobotics LTV called Flex. So that's the Astrolab FLEX, and we have some more stills. So you can see the crew can be in the top or the back there. This is NASA evaluating it, so you can see that there's trays you can pull out from different tools. We have it being evaluated here in the desert, and it's close up of the tires, the LS tires. So they do mention that it can go up 26-degree slope, which is steep slope, especially for the moon. On the moon, it's very hard to keep traction, so that is really the limit, 26 degrees. Any higher than that, then it would just would lose traction. And I think we have a video as well. So yeah, this is actually it's Chris Hadfield's one of these astronauts, but it's basically evaluating the FLEX rover. This is like laying down power cables, solar arrays, and driving the vehicle. So yeah, it can handle slopes. So yeah, it's a very versatile LTV, lunar terrain vehicle, and we'll find out, I guess, next year which one NASA selects. They're all be available on commercial terms, so you'll be able to purchase time to use these rovers, and they can be used autonomously, they can be teleoperated, or you can use crew. So you can basically do science even when there's no astronauts on the moon. Similar to the way that NASA controls the Mars landers from Earth. And it's going to be a lot easier from the moon. The moon's obviously a lot closer, so the delay will only be just a few seconds. So yeah, that's the news this week. So thank you for watching, and please like and subscribe. I'll see you in my next video.